Okay, so welcome to CUHK Open Innovation Lab. This is our first event in this term, so welcome you all come to this event. Although there are not many people, but I like the atmosphere because there are not many people represents, I can communicate better with you guys. So I'm Jonathan, I will be the speaker of today's sharing. And then what I'm going to sharing is called the LabView Programming. So first of all, today we will have a talk in front hand, and maybe this talk will last around maybe half an hour, and after that we can go to the room next room and we can have a window check, something like that. So let's begin our talk today. It's called LabView Programming. So how many people know about LabView before coming to here, or knowing these things before I host the event on the internet? Did you know that, Patrick?
One of my friends said he used LabView in his company, but I actually didn't know exactly what it's about, so
Okay.
But LabView is not free, right?
LabView is not open source software, but I brought this idea here because I can introduce the software here, because I use it for maybe half an hour and I find some funny things inside it. Maybe you can use the trial version or ask your company or your school or your supervisor anything and ask them to purchase a standard version. I think that one can already fit your requirement. Yeah, so what is LabView? LabView, the full name of LabView is called Laboratory Virtual Instrument Engineering Working Bench. It's a very long name, but we don't need to memorize it. We just call it LabView. Just like you put a lab in a computer, like you can view the lab with your eyes. And this platform is really famous for the language. It's a visual programming language. This is the company who invented it. And they call this language G language. Actually, I memorized it as a graphical language. It's called G language. Yeah, please see. And the most important thing of LabView is the visualized programming language. But they also have one thing, that is you can develop something to control the instrument. This one is also a selling point of LabView when they are trying to introduce the product. So what can we do with LabView? We can programming visually, use some flow graph, I will show you later. And also we can easily control hardware. So what does it mean? For example, today I took a hardware, it's called software-defined radio. It's one kind of instrument we can control directly using LabView. And also, if you know about Lego, the company who produced toy, this one, Lego. Did you know that? They also have a series of high-level toys called NXT. Actually, it's a robot. You can use LabView to programming a robot to ask him to do anything you want, like controlling the motor and ask him to see something or catch something. Use LabView. It's a very broad side of using it. And also, the interface of LabView is very friendly and very easy to customize. I will also show this to you later. But first of all, I may ask you a question. Is a graphical programming program good for us to do things? Except that LabView, what kind of language you regard it as a graphical programming things? Like we all type C, Python, and something else like that. They're all text-based, right? Do we have something like graphical based? Or not? Maybe it's not famous, but it's okay. Yeah, if you use some of them before, maybe you will have a taste of graphical programming. Maybe as a first come to our mind it's very simple to put something directly using graph. But there is another point you might need to take care of after you use this thing to do your project for a long time. That is, it will become very complicated if your project is very huge. And if you're working in a team, after you connecting those kind of stuff, it's not that good. So maybe after this PowerPoint you will think that, oh, why do I need to use the graphical language? If you are programming guys, this one is maybe not that efficient for you to develop something. But if you are not familiar with programming, like you are doing math, you are writing equation or something. If you are using this programming language, it's really easy for you to kickstart your project. Like one of my teammates who is not familiar with programming, he even doesn't know how to use Python, C, anything like that. He only knows how to type English words and something like that. But he used LabView. He just learned it for 1 week. And then he started to develop something inside software-defined radio. That's to define some radio electromagnetic wave in the Wi-Fi or something. It's really easy to start. And it's really easy to implement your idea. So let's come to a major part of today. It's called LabView Programming 101. If you haven't installed it yet, it's okay. I just try to give you a broad concept, a brief concept of LabView. And I will go through it, not that slow, maybe quite fast. Just let you see how to convert our programming skills into this one. Maybe before that, I can ask another question. Is it all of you know how to programming? Like using at least one kind of programming language? Yeah, maybe today you come here because you know programming, so today I introduce something new. But if you know programming, that's good, because we can learn it even faster than the starter, because we know how to do programming, and we can easily convert or say transform our idea from text-based programming to graphical-based programming. So first is the introduction of this LabView. Actually, it contains 2 panels. So forget about the text-based programming. We only have the text. We try to programming something in C. We just write all the text in the file, and then we compile it and get something. If you compile with a UI, then you get a graphical UI. But if you open a new project in LabView, you just get these 2 things. This one is exactly the UI you got for your user and for any people who want to use your program. And this one is the text of your program. And each block here represents maybe 1 variable or 1 function, something like that. And it's a flow-based, like you put some blocks here, the data will flow from here. It's like a sequential programming things. And first is the front panel. Here you can see this is the user interface you can create for your user or for yourself. It's all based on you. And they provide so many kinds of UI contents for you. Like, maybe I can use some mouse. Okay, like this one. This one is the numerical input. That is, input your number or something. And also, there are so many types of data you can input. And even the scroller is something you can also use it. Like this is the LED light, the switch, and even the graph. You can directly draw your data on the graph, just like in Excel or in maybe if you use MATLAB, you might be quite familiar with that. This is the front panel, and they divide it into 2 parts: controls and indicators, just like input and output. And this kind is the output, because they only output some data to show you, to indicate some data for you. And for that kind, the top left corner, that one is input. You input some number and the variable got its value. And this is the block diagram. Actually, this is the back end of your program. You can use some blocks and put into the block diagram and use some line to connect the blocks together, and then it constructed as a program, and it can work. So here I can give you a very simple example, that is add 2 numbers together, just like Hello World. But in LabView, if we try to do something like Hello World, it's too easy, I can say, because you just put an indicator there and set it as a constant value, Hello World, then it's Hello World. So here we can easily do adder, maybe we can say. Okay, so let me change it to, okay, you can see it already. Actually, this is the front panel. And if I open the back panel, it's really easy. Like, this is X, this is Y. And this is the other, just like the adding symbol in our text-based programming. And if I delete it and start from nothing, then it's like I put the numerical constant here. Okay, again, this is the front panel, just like the interface. Here, and A, B. Sorry. Okay, B. And the indicator. A plus B. Okay, and then what we can got. This is the input and this is the output. And then we can got 3 blocks inside the block diagram. You can regard them as the input and output of a function. Just like the parameters and return. Yeah, and then what can we do? We try to add them together. We find and add. And then, oh. And then add together. And that's the A plus B. You just need to do this kind of thing, and all the other things like compiling, data type or something. Of course, you can define your own data type, but you know, for a starter, it's really easy to kickstart. Like this one. You can also check like 2 plus 4. There we go. Okay, it works. So this is the first example for you. And if you want to try it by yourself, I also write all the steps inside the tutorial PowerPoint, and you can download it after this event, and you can try it by yourself. And yeah, also here, after you're doing it, there's some funny things like you can see each block have their own face. They have their own view. You can recognize each block's function, and after you're doing your whole block diagram, you can also edit it by yourself. You can edit it by yourself, like draw anything you want, just to let you know about what is the face of your function. And then because in graphical programming, when there are so many blocks, you need to make very careful how to recognize each of them clearly, or how to find one of the blocks easily. Then you need to make your function look like a very easy recognized one. So after that, here we come to some simple programming structure, like if-else, for loop, and while loop. Here we have some inspiration from the graphical programming, because sometimes it's not easy to graphically see a for loop or a while loop. How can they do that? Here first is the if-else case. Yeah, if you know about text-based language, if something, then we do something else, we do some other things. So in LabView, they combine if-else case with case structure. If you know about Python or C, they have something like, yeah, case, how to say? Like, like I define an A, and then case A. Oh, okay, A equals to 1, A equals to There's a more complicated if-else case. It's case structure, and let me try to combine them together. And how can you do that? Okay, here another example that I can show you directly. Case structure. Okay, very funny things that come to your mind. This is the case structure. What does it mean? Like I have an input. This is the input of the case structure. This one is not exist in text-based programming. We just regard it as a global variable or something like that. And here is another one. This is the comparator. If the input larger than 10, then we do something. Here is the maybe you can say conditional variable you can use to define false or true. If this one is true, then it will do something like add 5. If it is false, then we can add 10. This is just if-else case, but if you change it to something like A or something, that means the case A equals to A, or equals to B, or equals to C, something like that. So why they combine if-else and case structure together? And what this program means is that if the input is larger than 10, then it will add 5. Else, it will add 10. Maybe I can write on the blackboard for you. So can test this one, like you put a 4. Okay, 4 is smaller than 10, and you can add 10 and 14. And that's how it works. I think it's really easy for programming guys to understand this, but here we can have a taste of graphical programming. How can they do the if-else case, and even a more complicated one like the case structure. So let's continue. Okay, after if-else, there's another more complicated one, for loop. Like there are many types of for loop in each text-based language. Like in Python, we have for I in an array, and then we can do iteration of the array. Like maybe I can also write it on the blackboard. Like, can you see clearly? Clearer. For I in array, I equals to I plus 1 or something. Like we are doing iteration I inside array. Like for each item in an array, we can do something to it. This is a text-based one. How can we do that in graphical one? This one is quite funny. The first time I introduced these things to the people. As you can see, this one is the for loop. The for loop look like they have some of the input, n is the counting number. Like not to count, the termination number. Like when the number I means, or you say equal to n, it stops, it terminates. The I is the iteration number. It has to start from 0 to n. 0 to n. And then what can we do with I? It's just like for I in something, we can start from 0 to something. If you try to start from 3 or something, you have to plus the number. Like you want to start from 2 or from 3, then you need to I plus 1 or I plus 2. And then you get an output, and you can do something related to the for loop. Here is a very complicated case, but I will not introduce it here because, as you imagine, here we have an output. But for the output, there are a very complicated case. That is, whether we try to output an array or output one item. Here in LabView, they divide it into two kinds of output. One is called concatenated output. And because it's very complicated, I will not introduce it here. But this is the for loop. If you can try it at your home, and you will find it sometimes it's even easier for you to debug or say writing a program using for loop. And how about this one? For loop is originally from while loop. Why I say that? Because while loop is a more general one, a more general for loop, because we have a condition. When we meet the condition, we will continue do the loop or stop doing the loop. So here, this is the condition for terminate this structure. Like we have an input. Every time is the I is larger than the input, you will continue doing something. Else, it will terminate it. And output something, you go. Can Can you translate this one to a text-based? Text-based one? Like, for example, I input 2. I can write the answer on the blackboard. Or I can try for you. Okay, actually is okay, actually, if you, what kind of things do you do? You do 0, 1, and then when the I equals to 2 is equal to the input, and then if you send out a true here, and the while loop will terminate it. And here, if you just put every item together to form an array, we get an array. This is the data structure in LabView. Also the same as Python and even C or something. They all have data structure because data structure is very important in programming, right? Later I'll introduce data structure inside LabView. Yeah. So yeah, we just come to what I said, data structures, like arrays, cluster. Cluster is just like, if you know OOP, object-oriented programming. That is, you can form some of the variables, different types of variables into one object. Like a human, you have so many things inside you. Each one is a variable and they have a value. And the cluster is a collection of unlike data used for maintenance transporting. Yeah, it's like structure in C, object in C++. And in MATLAB, they also have struct. That is, you have some string or some text and some integer value and something else, and you combine them together, and we call it cluster. And how about arrays? I just introduced the while loop when we are trying to use the array as an output. Maybe you can try when you use LabView. And here, arrays, I just want to let you know that LabView have many functions you can do with arrays. They provide something like getting the size, building an array, find the maximum, minimum, or find the subset of it. There's so many functions LabView can provide to you. You don't need to write it by yourself. Like find the maximum, minimum. Also, in C they have some libraries, but sometimes you have a very complicated function. Like I want to find the maximum value of an array, and I also try to find the index of the maximum one. In LabView, they can directly give you an input array and an output. Maximum one, what is the index of maximum? That is, I'm not sure really, is that what I said? In LabView, they have a block. You input an array. They have so many output, and two of them, one is maximum value. Index of maximum value. They have some blocks like this one. You just input something and you get something out. So this is why I said it's really easy for the amateur or say starter of a programming world, because maybe it's not easy for him to try to write something to control the array or say get the things information from the array. But if we use this one, it's really easy to do that. So how about cluster? Cluster, as I said, is a structure of data that combine them together. And why we need that? Because when we have different functions and we try to pass many data from one function to another, we cannot do one by one. Like if we have three strings, three integers, maybe some other things like we have a timestamp and many things want to pass from A to B. We can put it into one cluster and you just pass the cluster to another one. And using that is really easy to pass the data. So after the programming one, I just go through it really quickly because I guess most of you don't have the LabView to try by yourself. maybe you can download a trial version after this tutorial and you can follow my presentation to do it by yourself. And here's some information for the icon editing. Just like I said, there's a face of each function and you can edit the icon of each function. And they also provide so many funny icons you can use for yourself. And how about the documentation of the function? They provide so many kinds of resources you can use. And in LabView, they also provide help function you can use for your programming. Maybe I can, here, I also already click this button. They have a context help. What can it help? It can show me what is the name, what is the data type, and even I put it here. What can I do? He can tell me what is the data type on this line. What can I do with this? Okay, this is constant with this data type, and even the scale of this variable. And this is the structure. This is the brief introduction of the structure. And also, he can give you some detailed help. If you click on it, it can show you very detailed information about case structure and even some. Okay, sorry, my computer is so slow. Yep. Here's the detailed help of case structure. This is a very powerful tool to help you understand each block. Just like you type in help something. Okay, that's it. That one is in the lab. I'm not sure if, maybe in Python you need to look online to find the details of each function, but in LabView it can provide it all for you. Because this one is a commercial product, so he needs to do everything for you, or nobody will try to use it. This is a good thing and a bad thing. Bad thing is that you need to pay for it. Maybe it's not open source. But good thing is that they try to earn your money. They will do everything for you to help you better develop your project or your product. So after all this, we have some showcase. First thing is FM radio station. If you come to our OL events last term, there's a person called Li Zhao who shared with us called software-defined radio. Don't be scared by the term. Actually, it's just like we use this device to define or say to send some radio signal, just like Wi-Fi or say FM radio station or anything you want. Just the wave, electric magnetic wave, you can define with LabView, and then use this instrument to send it out. So here's a demo for you. Okay, so this one is radio. Just like you hear the it's a noise. Actually, it's a white noise. So what will we do with that? Okay. Oh, because I opened too many things. Please wait a minute. Okay, here is the front panel. Just like the user interface, you can ask your user to input every parameters for your programming and for your program. And you don't need to care about this one, but if you are interested in it, I can share it online. If you have LabView, you can try to see what is each block doing. But it's not very hard. If you look at the text-based programming in radio, software-defined radio, it's very complicated. Like it took me over 3 months to learn the basic knowledge in software-defined radio. But in LabView, a student who's taking a course in our school, he used 2 weeks, can try to do something like this one. So this is what I call is really easy to start. So now let's try something. Okay, let me see where's the frequency. Okay. I already prepared something like this one. Okay, it's generating some waveform. This is the waveform that I generated with these devices. How can I prove that? If I remove the antenna. Okay, there's too close. If I remove, yeah, just like I stand here, there's no noise. Yeah, so you can do a FM radio station by yourself if you're using the programming language, and of course using this device. This one is not cheap. It's a little bit expensive, but they also provide some funny toys similar to this one, and it's really funny to do your own FM radio station. To try something out using a radio and using a very easy start programming. Okay, so here's one showcase. Another one is the Lego NXT. Although I didn't bring the hardware here, but I have a funny video. Wait a minute. Okay, yeah, sure. Oh yeah. Remember one more thing? Like, what can LabView create for you? Like some guys, they are crazy about the solar system. You can even use LabView to generate a solar system for you. Like, you can write a program to show others how the solar system works. That LabView is very powerful to do anything you can think of, even the graphical one or the sound. Although the front panel looks quite simple, if you go to the background, like this one, they have so many things to show you this program. But even you use text-based one, I guess you try to generate some functions or say like the graphical model, it's still not easy. But this one can be more user-friendly. Why I say user-friendly? Because you try to change the user interface. In text-based, you need to set the coordinator of each component. Like I set it to 100, 300. In LabView, you can just, okay, I put it here. I put it here. I don't want it shown here. I want to show it here. You can just change it everywhere you want. Then you can even make it flatter. Everything just like click and drop, and it's a very graphical way.
Have you used the Visual Basic or Visual C from Microsoft?
Visual C. I also use that, but
so they have a similar thing, like they set up the GUI and
yeah, set up the GUI.
Putting the tab, display text box, something like that button. But of course, the back end is still the source code in line by line basis, not the graphical one. But I think the front end is similar to the concept that LabView has been using now.
Yeah, you're correct. You're correct. This one is similar to Visual C or Visual C++ or something.
Yeah.
Yeah, like C#, they now emphasize on the MFC model. And they emphasize on this kind of similarity, simplification. But in LabView, because it's all practical, so for starter, it's really easy to start. Right? Although you look at very complicated, But if you start by yourself and you connect one by one, after that it's not hard for you to read it by yourself. And also you can add some label, just like documentation, and anything you can help the others to understand your code. So last one is, because we don't have sound here, I'm not sure we can